the previous videos, we mentioned about the characteristic of a good title. It comprises the purpose, topic, and focus. We also mentioned about the common mistakes while constructing a title. The idea here is not to confuse the reader. After that, we discuss an example of a title, particularly in terms of the adequacy of the title to reflect the content of the research study. You will have to be careful with the terminology used in your title. Let us look at another example of a title. We are talking about an appropriate terminology used in a title. The diagram here shows the specimen being tested in a research study. It is a reinforced concrete beam. Experimental test was conducted. The beam was tested under the load setup of 4-point load test. This kind of testing is normally considered as a simply supported beam. And this reinforced concrete beam member is slightly different than the typical reinforced concrete beam, where the researcher placed a lot of sphere made of polystyrene inside the reinforced concrete beam. This will be the side view of the member, and this is the cross-section of the member. The line here represents the reinforcement in the beam, and the beam member is made of concrete. Assuming that you have not encountered this kind of design before, let's say now it is totally a new design. Nobody have studied it yet, and nobody have given any names to address it. Now you would like to address this kind of design. How will you call this kind of beam? It is definitely not a typical reinforced concrete beam, as a typical reinforced concrete beam do not have polystyrene inside it. The purpose of incorporating this polystyrene in the member, it is to replace the concrete, which is heavy, with the polystyrene, which is lighter. Presume that the purpose is to reduce the weight of the reinforced concrete beam. So now you need to determine which of these three will most appropriately represent the member. Are you going to call it as the lightweight reinforced concrete beam? Or is it a voided reinforced concrete element? Or is it a polystyrene infilled concrete member? Think about it. You may pause the video for a while and determine which will be more appropriate representing the member. Okay, now let me give you some directions before you decide the appropriate naming to address this kind of design. Your ultimate purpose here is for you to construct the title. Maybe you need to diagnose the respective member as well as the relevant terminology and choose the one best reflecting the condition. First, you know that it is a reinforced concrete. The members is made of concrete and steel, and we know that it is a reinforced concrete. And we can look into the type of the member, which is normally defined by the directions of the load. The load is subjected laterally to the member, which is perpendicular to its longitudinal axis. This kind of member is normally known as the beam. Therefore, we can call this member as reinforced concrete beam. Now we look into the three terminologies in the titles here: lightweight, voided, and polystyrene. the term voided now is totally out, as the sphere here is actually a polystring. There is no void here. You may only use the word voided when this place is a void. Something like when you have hollow sphere. Therefore, you will opt this out as a voided. What's left here, it will be lightweight and polystring. You know that the purpose of incorporating the polystring in the member, it is so that the member become lighter. So it is okay for you to use the term lightweight, as it is lighter than the typical reinforced concrete beam. However, it is not as precise. Another thing is, when you talk about lightweight, especially in terms of the concrete, there is a clear definition in terms of the lightweight, normal weight, and heavyweight concrete. The standard defines the lightweight by a certain range of density. Therefore, if you use the term lightweight, it might give the reader a wrong impression that this kind of concrete being used to cast the member is a lightweight concrete. On this basis, the term polystyrene is most likely going to be the most accurate among the three. Next, we look at the type of loading. What kind of the load that you apply onto the member? Is it going to be a static load or a dynamic load? The differences between the static load and the dynamic load is that whether the load is remain constant, placed at the stationary conditions, while the dynamic is referring to the moving load or fluctuating loads. The term monolithic here is not appropriate to describe a load. Monolithic is actually referring to a monolithic member which is cast in one piece. The proper term will be the monotonic. You may use the term monotonic or static load interchangeably. Sometimes you see some papers use the term monotonic, while sometimes you see static load. They are referring to the same thing, only that when you choose to use either one, you need to be consistent throughout your paper. Personally, I will prefer the term static load. It provides an impression that the load is placed at the same place. And then you might want to know the conditions of the load. Let's say incremental. The incremental means that the load is gradually or staggeredly increased until the failure of the member. Some other terms that you may observe from similar testing under different kinds of loads include the cyclic load or cycled load or fatigue load. You will have to study the definitions of these kind of loads. Each of them carry different meanings. You have to be careful. And then you might want to know what kind of load that you are simulating in this experimental setup. Are you simulating the flexural conditions, or are you actually looking for the shear failure? Whether it is considered as flexural or shear load, it is very much dependent on the 2 point loads acting on the member caused by the static load. Simply said, if the point load is close to your support within a certain range, the shear failure of the member is likely. Therefore, you are actually simulating the shear condition. And if you have this point load further away from the support, exceeding certain range in terms of the distance by its depth of the member, the flexural failure of the member will be observed. Then you can address that as the flexural load. Other than that, you will need to clearly define the focus of the study. Are you looking for the structural behavior? Or are you evaluating the performance of the member? Or do you intend to do classifications of the member? Or you want to know the strength of the member, acquire the deflections of the member, or your focus is on the ductility of the member, and so on and so forth. These terms may look similar, but by their definitions, they are different. You will need to choose one which is most closely reflect your scope of your study. Then you would like to look into the type of your study, whether it is an experimental study, a numerical study, an analytical study, or a feasibility study. Again, each of them represent different nature of the study. Experimental study is that you're going to do experiment to test the actual specimen. Numerical study involves some computations and modeling. Analytical study is normally related to the derivations of equations. And the feasibility study is with the purpose to determine whether this kind of member is applicable under certain circumstances. Having this being clearly defined, I guess you will have a better idea how you're going to construct a title related to this research. Again, maybe you can pause the video for a while, trying to construct a title that describes this research. Try it and you will find it interesting.